Hi everyone, welcome to CodeTav Management. So today we will start with the solid principles, which is one of the best topics in our software development uh, work life. Okay, so basically, almost everywhere when we talk about the delivery of a product, so the first steps comes in our mind, that is design. So we need to design before developing anything, right? So the more focus we put into the design, the better the product will look. Okay. So every design has some design principles and that need to be followed while designing a product. So hence designing principles uh, have a crucial role, right, in any product delivery. So what is the main topic? Designing principles. Okay. So there are a lot of design principles, but we will discuss about the solid principles, right? So what is the solid actually? So basically there is SOLID, right? So what is this? S means, this S means nothing but the single responsibility. So S means the single responsibility. So what is the single responsibility? So single responsibility means a class should have only single responsibility and should have one and only reason for the change. There will not any other reasons. So only one reason will be there for anything change. So one class will have only one responsibility, that is single responsibility. Next is O. So what is this O? O means the open closed principle. Okay. So what is this open closed principle? Means a class should be open for the extension but closed for any modification. Okay. Then L. L means Liskov substitution. Okay. So what it means? It means like objects in a program should be replaceable with the instance of their subtypes without altering the correctness of the program. So we can replace the objects with the instance of the subtypes, but there will be no change on the program. Okay. We will not modify or we will not correct anything on that program. Okay. Then next is I. So I means interface segregation, right? So this means segregate the interfaces as per the requirements of the program rather than the uh, general purpose implementation. So we will just segment for, means we will just segregate uh, according to each requirement. We will use each interfaces. That is basically interface segregation. Okay. Then D. D for dependency inversion. So this means it should depend on abstractions rather than the concrete implementations, right? So basically I and D means interface segregation and dependency inversion. So basically we will just depend on the abstraction. We will not depend on the implementations, right? So also we segregate the interfaces as per the requirements. Okay, these are the solid. So single responsibility, open closed principle, Liskov and substitution, interface segregation, D for dependency inversion. Okay, these are the solid principles. So I will first tell you about the, you have heard about the design patterns, right? But before that, we also need to learn about the design principles. Design principle and design pattern. Okay. So what is the design principle? So design principle basically a set of generalized pieces of advice or proven the good coding practices that are used as rules of thumb when making the design choices. Okay. So they are a bit similar concept of the design patterns, but main difference between that design principles are like design principles are more abstract and generalized. Okay, so here you can uh, take the first point as design principles, basically more abstract and generalized, right? And they are kind of high level pieces of advice, often applicable to many different programming languages or even different paradigms. But design patterns, on the other hand, they are also abstractions or generalized good practices, but they provide much more concrete and practical low level advice. Okay. They are also abstract and generalized, but more concrete and low level advice. Okay. So these are the main difference, but they are related to entire classes of the problems rather than just generalized coding practices. So design principles encourage us to create more maintainable, understandable, and flexible software. Okay. So as our applications grow in size, we can reduce their complexity and save ourselves a lot of headaches for further down the road. Okay. So uh, basically software design is not perfect if it is executed in a single attempt, so there is always a possibility to change it and make it even better. We will further we make the software more readable, more flexible, more understandable. Okay, so regular basis change will be there. Okay, so it will be helpful for the users and also the developers. Okay, and as if you will make your code base more readable, then the future developers will easily understand the code base and can develop the features and debug the code in a very easy way, right? So that's why main thing is design principle. So first of all, we need to take care of the designing. After that, we can develop. Okay. Okay, so first of all, I will tell you what is code rot. So what is this code rot? So when developers work on the design without using structured design principles, they can create long-lasting problems for the future developers. Okay, working on the projects and limit the potential success for the application they are developing. So these issues are commonly referred to as the code rot. Okay. So if you want to change your programs during any upgradation of the software, you should avoid the factors that can cause the code rot to happen in the future. Okay. Otherwise, the future developers will face some problems. Okay. So hence you can make your software up to date and the people can continue to use it for years to come. Right. So that's why we need to avoid the code rot. So when actually developers don't give much time about the design, okay, proper structured design principles they will not maintain. For that time, they will face some long lasting problems and it will create some issues for the future developers. This is basically the code rot. Okay, so can we identify how to identify the code rot? Okay, so for that reason, you need to check several things. Like first of all, you need to check the rigidity of your code. So small change causes the entire system to rebuild. For that case, you will find that your code is more rigid. So this is one identification mark for your code rot. Then fragility. So what is this fragility? Means changes to one module cause the other unrelated modules to misbehave. So you already made some dependencies between one module with the other module, which is not good. So when some issue will occur in one module, and if the other modules will suffer for that, then this is not a good practice, right? So this is the fragility basically. Next is immobility. So what is this immobility? So a module's internal components cannot be extracted and reused in new environments. So for example, like if an application's login module cannot be used in entirely different system, then this module is immobile, caused by couplings and dependencies between the different modules. The strategy is to decouple the central abstractions from low-level details, like a particular code-based schema or UI implementation, like the web applications or desktop applications or specific frameworks. Okay, so when a module's internal components cannot be extracted and reused in new environments, that is your immobility. Something, some feature you have used for your one module, but the same feature, suppose it's required for the another module, but you unable to use that same feature. This is called the immobility. Okay. Then I can add like viscosity. What is the viscosity? So when building and testing are difficult to perform and take a long time to execute. So when even a simple change is costly to make and requires you to make changes in multiple places or levels, that is basically the viscosity, right? So these are basically the identification marks for the code rot. Next are like what are the benefits of the solid principles or why we use. You need to know first like what is the solid principles. Here I have discussed like what is the, when you read anything, so first of all you need to know basically what is this thing, why we will use that one. Okay, so why solid principles? So basically what you means, what is the solid principles, you read it, but why the solid principles means the benefits of the solid principles. So first of all, to make it easier to quickly extend the system with new functionality without breaking the existing ones. So if we don't do implementation of a new feature in the application sensibly, then it may even affect the existing functionality and cause unintentional issues. Okay. Next is like to make the code easier to read and understand. Thus, spend less time figuring out what it does. If our code does not follow the solid design principles, we generally take more time to understand what it does. The solid principle approach ensures that your code is relatively easier to read and understand. And third one is like to make the code more maintainable. Okay. Fourth one, you can say like every software needs upgradation time to time. So therefore, we need to build applications while keeping in mind the possibility of future changes. So it is quite effortless to refactor your code with the solid principles. And lastly, I can say like if we apply the solid principles in the code, it will also ensure an easy debugging process as a whole. So first, like easy to extend the existing code. Then second is easy to read and modify the existing code. Three, you can say more maintainability. Four, you can say like um, easy to upgrade time to time. Next is easy for debugging. Okay, so these are basically. So now we will know about like S for the single responsibility. So this is the time to discuss about these solid principles. The first one is like single responsibility. So this principle basically says that there should never be more than one reason for a class to change. So a class should be focused on a single functionality address a specific concern. So this means that every class or similar structure in your code should have only one job to do. Everything in the class should be related to that single purpose. That is, be cohesive. It doesn't mean that your class should only contain one method or property. That's not. Like the more responsibilities your class has, the more often you need to change it. So if your class implements multiple responsibilities, they are no longer independent of each other. Therefore, you will need to change your class means consequently. Okay, more often you need to change. So it will have more side effects and requires a lot more work than it should have. So it's better to avoid these problems by making sure that each class has only one responsibility. So this is the main point. Okay. So responsibility will be one, but multiple methods can be there. Okay. So I'm giving you one example. Like suppose you built your software over a longer period and you need to adapt it to ongoing change requests. So you might feel the easiest and fastest approach is adding a method or functionality to your existing code instead of writing a new class or component. But that often results in classes with more than responsibility and makes it more and more difficult to maintain the software. So you can avoid these problems by asking a simple question. Always you suppose there is a new questions means new features you need to develop. So first of all, when you will do like means you will think like if I will add that methods in that class, so it will be easy to develop for me. But before that, always ask a simple question that what is the responsibility of your class or component or microservices. I'm writing that questions again. Why uh, I am mm, uh, writing in the class or component or micro services. What is the responsibility? This is a big question. Okay, so if your answer includes the word and, okay, if you will include the and, then you are most likely breaking the single responsibility principle. Okay, then it's better to take a step back and rethink your current approach, and there is most likely a better way to implement it. Like, let's understand the solid principles, the single responsibility principles with the example. I'm giving you one example. Suppose I'm giving you one example which violates the single responsibility principle. So what I will do, like I'm creating one class which is suppose resume class. Okay. Then I'm using two parameters. So for the resume, let just add like one is like technology, and another is years of experience. Okay, these two we have taken. Just we will do the getter method and setter methods. Okay. It will return technology in the same way. Now I'm writing the setter method. So public void set technology. I'm passing that string technology. Okay. And here I will use that this technology only. This technology equals to technology, right? So next of all, I am creating the getter method of that years of experience. So public integer years of experience, right? And here I'm just return years of experience. Okay. Next one, what I will do, I'll just make the, this is the getter method, right? So get years of experience. Next is, so public void set years of experience. Okay. And here this dot years of experience equals to years of experience, right? And I'm writing, just I'm adding this and word, right? That means it's violating the single responsibility principle, which is like public void and suppose search resume. Okay. So there are some logic here. You can add that one logic for the search resume as well. So when you will do this and word, means like there are methods like for the technology and also for the years of experience. Also you were adding like for the search resume. So responsibility becomes more. Okay, that's why there is no single responsibility. That's violates the S, means single responsibility violates. Okay, so here basically in this code it violates the single responsibility principle, as the resume class has two responsibilities. First, it sets the properties, which is the technology and the years of experience related to the resume. And second, it searches the resume, okay, uh, for the resume in the repository. And the setter methods can change the resume object, which might cause some problems. So the setter methods will, when change the resume object, then it will create some problems when we want to search the same repository in the repository. I mean, same resume in the repository. Okay. So basically for that setter methods, you will not able to find the same resume in the repository again. So it creates some problems, right? So this is basically the violation. So how we will uh, 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 resolve this problem? So you need to follow the single responsibility principle. So now, example which follows. So for that reason, what I will do, I will make one class for this resume. and another class for that uh, repository view, and from that you can use the method search resume. Okay, so there will be now single responsibilities, right? So first of all, what I will do here, the resume class. Okay, this is the resume class, what is done. And then we create the another class, which is the repository view. And here, this is the resume property. So now, inside the repository view, you means I will make one uh, constructor for that. So public repository view, and here I'm passing the resume, right? And this resume is the resume here. And then I will just make the method like search public void search resume, right? And inside that your logic will be there. Okay, so here basically you can see that how this changed. Okay, so if you want to know about the actual workflow for that, I can draw like UML diagram as well for you, so you can you diagram. So before, what is there? So before, what is there basically? So the resume class was there at first. Okay, and there are you think this is like a box. Okay, just think. Then resume class was there, and two parameters were there. So one was technology, which was of string type, and another one was the years of experience, which was of integer type, right? And then some resume, like search resume method was there. So I'm just writing this resume. Okay, so means this resume. This is so inside the resume class, what were the methods actually? So I'm writing means search resume method was also there. This is search resume, and you can write it as in this way. Search resume method was there, and also the get technology method was there. Then set technology method was there. So get technology, this type I can write like this is string, and the set technology which is passing the string, and this return type was like void. Okay, then your get years of experience was also there, and it was of integer type, and set years of experience was also there, and this is integer, and it is also void type. Okay, means you can pass here like int. Okay, so this was the previous UML diagram, and after that what we have done. So after, what changes we have done? So here the same suppose resume class is there, And inside that, we also have included the same technology and years of experience. Okay. And after that, what we have done, we have included only the um, resume method. Like you can means you can write like here. This is the resume class. For the resume class methods, means it is indicating like the methods of the resume class. Okay. So another was also there. You can here include this search resume. Okay. And it was also void. Okay. So hmm, this is here what are there. So here this was also there, means these parts, these are also there, but here some repository view was there. Okay. So I am indicating in that way. Mm, 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 mm. Also here the repository view, repository view class is there, and under that there is no such parameters, right? Means this resume, this is there. So I'm just assuming here. So repository view, and inside that we were passing that resume, right? And then we are just search resume. Search resume was there, and the return type is void only, right? So this is the after UML diagram. So these modifications we have done. Okay. So I'm giving you, or you can say like I'm asking you, suppose another example. Okay. So suppose public class employee. Okay. This is another class. Then some methods are there, like public void um, calculate pay. These methods are there. Something is there in this method. Next is public void, then save employee. Okay. Next is public void, then get employee report. Okay. Suppose this one. So then if I will ask you how many responsibilities are there, first think about it. How many responsibilities are there in this class? There are three responsibilities, right? So the correct answer is three, right? Three responsibilities are there, right? So here we have the calculation logic. Next is database logic, and uh, reporting logic as well. Okay, so all mixed up within one class. So if you have multiple these responsibilities combined into one class, it might be difficult to change one part without breaking others. So mixing responsibilities also makes the class harder to understand and harder to test. So it will also decrease the cohesion. So the easiest way to fix this is to split the class into three different classes, with each having only one responsibility. So uh, one will be for the database access, one will be for the calculating payment, another one will be the for the reporting. Okay, so all need to be separated. Okay. So It's violates. This is the violations. Okay. So what modifications we can change? Modifications. So I have told you, like, you can create this public class employee, but this is for employee payment. Okay. And here you can um, add the method like public. mm, mm. So when you will calculate this payment, this you can make it as double type. Okay. So means when we'll do the payment, that can be double format, right? So that's why I'm just writing. So you can add this method here, and inside that you can write your logic. Okay. Logic for the employee payment. Next, you can create the next class like public class employee. This is for your repository, right? So inside that you can add this method, and inside that you can write your logic there. And next one is employee report, and inside that you can write this get employee report method, right? So in this way you can segregate this. So now we can call these methods from the respective classes wherever it is required. Okay. But don't get confused with the fact that a class will have only one method to follow the single responsibility principle. It can have many supporting methods, but they should not change the responsibility of the class. Okay. So if you will do like here inside that calculate payment, okay, then suppose add payments, then subtract payments, multiply payments, okay, then suppose divide the payments, means in that way you can add this inside the same class, as those are for the same type of responsibilities. Okay. So this is actually, you can do that one, but this is not a good practice, right? So if you want to discuss about some other solid principles, like you can also uh, continue this lecture, uh, like imagine there is a class which performs some operations. What are operations? Like connect to a database, then read some data from the database tables, and finally write it to a file. So have you imagined the scenario? I'm just writing the, okay, first of all I'm writing the other examples. Okay. So inside that I am writing some scenarios. First of all, connect the TV. Okay. Okay. Yeah. Next one is read some data from DB tables. And third in write it into a file. Okay. So have you imagined this scenario? So here the class has multiple reasons to change, and few of them are the modification of the file output, new database adoption. So when we are talking about the single responsibility, we would say like there are too many reasons for the class to change. Hence, it doesn't fit properly in the this example demonstrates the code that violates solid principles, the single responsibility principles. So for example, let's consider an automobile class which can start or stop itself. But the task of washing belongs to the car wash class. So a book class has properties to store its own name and text, but the task of printing the book must belong to the book printer class. The book printer class might print to console or another medium, but such dependencies are removed from the book class. Also, you can imagine about the uh, entity manager. Yeah, entity management system. So you can find lots of examples of all the solid design principles in an open source software and most well-designed applications, such as your Java persistence layer and the popular frameworks and specifications which you most likely use to implement it. So one of them is the Java persistence API. Okay, you know, right? The JPA, Java persistence API. So that specification, so it has one and only one responsibility, defining a standardized way to manage the data persisted in a relational database by using the object relational mapping concept. The entity manager interface provides a set of methods to save, update, remove, read entities from a relational database. So its responsibility is to manage the entities that are associated with the current persistence concept context. So if you put more than one functionality in one class in Java, it may introduce coupling between two functionalities. Even if you change one functionality, there is a chance that you broke another functionality. Therefore, it will require another round of testing to avoid any surprise on the production environment. So these are the issues. Okay. So again, I am going to discuss like what are the benefits for the single responsibility principle. So first one is like easier to test. So a class with one responsibility will have far fewer test cases, which results in very less efforts in testing. Again, the benefits I am discussing. So first is easier to test. Second one is uh, low coupling. So means less functionality in a single class will have fewer dependencies, hence it will lower the coupling. Okay. Next is better organization. Okay. So what it means, like smaller, well-organized classes are easier to be searched by a first-time code reader than big ones. Okay. So this one is, next one is like easier to implement. Okay. So means classes, software components, and the microservices that have only one responsibility are much easier to explain, understand, and implement than the ones that provide a solution for everything. So this reduces the number of bugs, improves the development speed, and makes your life as a software developer a lot easier, right? So easier to implement. Next is easier to maintain. So by making sure that your class has only one responsibility and you can save a lot of efforts in developing the application and create a more maintainable architecture. So that's all about the solid principles, the single responsibility principle. Okay, means the first one for the solid principle we have covered. Okay, so next we will discuss about the open closed principle, right? So that's for all today. So we have discussed what is the solid principles. Next is what is the difference between these design principles and design patterns. Then what is about the code rot. Then why solid principles. Okay. Then example which highlights the single responsibility principle. How we can follow the single responsibility principle with example, and then the UML diagrams also, that like before what was there and after that what was there. Okay. Uh, After that, again, I have explained one violations and modifications, what we can do. Some other examples you can also consider the entity management system, there's the JPA, Java Persistence API, and some benefits of that. single responsibility principle. Okay. So that's all for today. Okay. If you like it, just do like, share, and subscribe. Thank you, everyone.